They have given the respective displacement of the particle of mass m for various values of t. Okay, now they are asking us to identify which of the following statements is true. So in order to understand that, first let us go to the option A. Option A says that the force at t is equals to 1 by 8 seconds on the particle is this. So now they are asking the force at t is equals to 1 by 8 seconds. So in order to find the force at t is equals to 1 by 8 seconds, first you need to find the acceleration at t is equals to 1 by 8 seconds. In order to find the acceleration at t is equals to 1 by 8 seconds, first you need to differentiate the velocity function, which is defined at t is equals to 1 by 8 seconds. Okay, means it's a domain. The velocity functions domain should include 1 by 8 seconds value. Okay, t is equals to 1 by 8 seconds should be included in the domain of this function. So in order to get that velocity function, first you need to differentiate the displacement function, which include in whose domain the t is equals to 1 by 8 second is present. So when we observe here, we can observe that as 1 by 8 seconds is greater than 0 and less than 1 by 4, though then this t value, this 1 by 8 seconds, this time value is defined over here. So for this value, they have defined the function x of t as in this manner. So we have to consider this function. Okay, understood? Which function we have to consider, why we are considering this function is also necessary to understand. So I am considering that function because my t is equals to 1 by 8 seconds will be in that domain. Okay, so I am considering x of t is equals to a sine 4 pi t. So now they are now in order to find the acceleration, first you need to differentiate the displacement with respect to time so that you will get obtain the velocity function in terms of t. When you differentiate, as a is constant, differentiation of sin x gives cos x. So here again on further differentiation you get 4 pi into cos 4 pi t. Now again we need to differentiate velocity to get the acceleration. So acceleration is equals to dv by dt. Okay, is equals to when I further differentiate, a 4 pi is a constant, so I am keeping it separate. When I differentiate the cos x, I get minus sin x, and further differentiation I get 4 pi because d by dt of t is equals to 1. So here I get minus 4 pi because d by dx of cos x is minus sin x. So minus, here my sin x is sine of 4 pi t. So when you further write in the simplified manner, you get the acceleration as minus 16 pi square a into sine 4 pi t. Now they are asking us to find the force at t is equals to 1 by 8 seconds. So in order to find that, we need to find first acceleration at t is equals to 1 by 8 seconds. So we obtained our acceleration, this a of t. Now we need to find the acceleration at t is equals to 1 by 8 seconds. So a of 1 by 8 seconds, that is equals to minus 4 pi square a into, here when I put t is equals to 1 by 8, you obtain that 4 pi into 1 by 8 gives, on cancelling, pi by 2, that is sine of pi by 2 is equals to 1. Right, sine of pi by 2 value is equals to 1. So you obtain that acceleration is minus 4 pi square a sine pi by 2, that is nothing but acceleration value is minus 16 pi square a. So when you put here, you get mass into acceleration is minus 16 pi square a. That is when you further arrange in the manner, you get minus 16 pi square am is your force acting at t is equals to 1 by 8 seconds. So our option A is true. Okay, when you match, our option A is true. Now moving for option B. Option B says that the particle acted upon by a impulse of the magnitude. Now they are asking us to find the magnitude of the impulse at t is between the time t is equals to 0 to 1 by 4 seconds. So in order to understand that, first you need to understand the definition of the impulse. What does the definition of impulse is? Let us see. So we know that the impulse is j bar. It's denoted by j bar. It is actually the large force acting in a short period of time. And they have given the period of time as 1 by 4 seconds minus t2 minus t1, that is 1 by 4 seconds minus 0 seconds, multiplied by maximum force. So we already obtained that our f of t was, when we in the previous case our f of t was minus 16 pi square am sine 4 pi t. So in order to get the maximum value of force, we need to get the maximum value of sine 4 pi t. So maximum value, our f will be maximum when our sine 4 pi t value is maximum, because these all are constant, it doesn't affect. So our t, it will be maximum when this value is maximum, and we know that sine 4 pi t is maximum value is equals to 1. So our f maximum will be, minus 16 pi square a into m is our maximum value. So I get the impulse as minus 16 pi square a into m multiplied by 1 by 4, which gives minus 4 pi square am. Now it is a impulse. Now they are asking us to find the magnitude of impulse. So when I find the magnitude of this impulse, it is 4 pi square am. So our option B is also true, because they are asking the impulse between 0 to 1 by 4 seconds, that is 4 pi square am. Coming to option C says that the particle is not acted upon by any force. It is wrong, because we have seen that the particle was acted upon by a force of f of t, and we have calculated that also. So our option C is wrong. Moving to option D. Option D says that the force acted on the particle is not acted upon by a constant force. It is true, because we have seen that the particle was acted upon by a force which directly depends upon the t value. Okay, our force is depending on the t value. It is not always constant, it varies with the time. As the time value as the time varies, its force will also varies. So our option D is true, because the force is not acted upon by a constant, the particle is not acted upon by a constant force. It is acted by a varying force. Moving to option E says that there is no impulse acting on the particle. It is wrong, because we have seen that we got the impulse value and magnitude, and we have seen that there is an impulse acting on the particle between 0 to 1 by 4 seconds. So our option E is wrong completely. Now A, B, D options are true.